So hello everyone who is watching live now and those who are watching after the stream has come to an end. So here we are in day 11 of 150 days of solving DSA, solving top interview 150 problems. We are having given an integer array nums, right? We are just solving the 11th problem in the top interview 150 problems, right? So h index. This is the question which we're gonna solve now, right? So we are given with array of integers which is called as citations, where citations I is the number of citations a researcher received for their ith paper. I think you got it. Return the researcher's h index. Let me tell you what does a h index mean. H index mean if just imagine like this, h index mean the h index mean the number of papers, h number of papers h number of papers got more than h citations. If you say h index is equal to 1, there is like at least, if I can say, at least one paper got at least one citation. That's it. Let me say that h index is equal to 3. Then at least 3 papers got at least 3 citations. 3 citations. I think you got it what I want to explain you, right? So h index is equal to h. Let me write h index 274 h index, right? 274 h. One second. H index. All right. Yeah. This is the LeetCode problem number 274 h index. Now, here I'm just changing it. Wait a second. I'm just removing it. This has been something. Yeah, here. I'm just removing it. Now you can see it's full screen. Okay. I don't know how I got it. So h index is equal to h. That means at least h papers got at least h citations. Let me take the example which I have had here. Now 0 1 1 2 4 4 5 8 9. If you see I have 9, you know one thing, I can choose 9 but what I think is, do I have, do I have, here I would ask one question, right? Do I have nine papers, nine papers with at least nine citations? No, I don't. So this would not be my answer. Then, I'm not traversing through the array. Instead, what I'm doing is I would go from 9 to, let us say, the H index will be 8. Now I'll go to 8. How many are, I have 8 8 papers with at least 8 citations. Greater than or equal to 8 papers, greater than or equal to 8 citations. No, we don't have. Now I'm changing the H index to 7. I'm just decrementing, right? So now you see 7. I need at least 7, but I only have 2. Now decrease this to 6. Even then, I have only 2 papers uh, with 6 citation, with at least 6 citations. But that's not my answer. I'll go forward, right? Now I have 5. Now I'll check whether I have cite at least 5 papers, at least 5 papers which are having at least 5 citations. No, I don't have, right? So what I'll do, I'll just decrement the H index to 4. Now, if you see clearly, I have 4, right? Right? I have 4 papers with at least 4 citations. That's it. That's it. I have at least 4 papers with at least 4 citations, right? So my problem is simple. I need to find maximum, maximum number, nothing but the H index, where H index is nothing but at least H papers with at least H citations. I think that's it. We are clear, but I can sort it 0, 1, 2, 4, 5, 8, 9, 0, 1, 2, 4, 5, 8, 9. You see here, let me say the H index is equal to 9. That's what I start with. Here it is, right? Now I'll decrement. I'll just check what are those papers, valid papers, right? So I didn't find it, right? So what I'll do, I'll just get valid papers with citations uh, with at least 9, right? So those are only one. So these valid papers are lesser than H index, right? So what I have to do, I think I just need to decrement the H index. Then it would be 8. See, you can see here, H index has become 8. Now what are the valid numbers? That's where the problems goes difficult. How can I go to here, right? Okay, let's go. And I'm just decrementing the H index. It is the 8, but even then I get the valid papers equal to 1. I can even decrement it further. But what if I use a hash map here? What if I just say 0 is for one time, 1 is for... Okay, I think it's not a correct way. It just gets... Which problem we are solving is 274 H index. Let me take that here. Right, so um, I'm thinking like, once again I got some live chat. You can ask your doubts right here itself, don't have to wait. What if we have these nums, sorry, these citations in a different manner? Let me tell you how. If I have 98544, um, 985442110. Right, now what I'll do is I'll start, the maximum H index I can have is 9, right? So let me say, let me start from the right here. If you see, it is just 0, and this, is it greater than or equal to the H index which you are looking for? No. So what I'll do, I'll just go here. Is it greater than or equal to H? No. Here, no. Right, then here, no. So the iterator will stop here at 9. Now the here this nums of I is greater than or is equal to H, which H index which I have just chosen. Now this is just 1, right? So is 1, I'm just getting the valid papers, right? So I'm just going from here to here, here to here, right? So what I'm doing is I'm just going from H index is equal to the max number to 0, right? Now I'll check whether whether there are, once again I'm just missing this thing, 274. This is our problem number. Okay, check whether there are at least H, let us say this as H is equal to max number, right? H, check whether there are at least H number of valid papers, right? So if so, return H. If not, we just do continue it, right? Now uh, there is one thing which I want to tell you is we can write the algorithm here. Let us say first thing which we have to do is sort. Let me write the algorithm. First, sort in descending order. Then you will say, let us say h is equal to nums of 0. H is greater than or equal to 0. H minus minus. As I said, I'm just going from the top to, I'm just decrementing the h, right? So then what I'll do is I'll just I'll just have I is equal to n minus 1, I is greater than or equal to 0, I minus minus. I'm just having these all, right? I'm just taking it as nums. Now if you see, I'll just check if nums of I is greater than or is equal to h, and if I plus 1, if so I plus 1 is greater than or is equal to h, then we'll just return h here itself, return h here itself. Now if not, we'll just break the loop. If you know these, all these numbers are, let us say with this h index is 9, but I think we can take another example, like yeah, here it is 2, right? Here it is 2, the valid papers are 2, right? Now if these valid papers are not, that's the all those valid papers, that's it, right? So instead of writing it as I plus 1, I'll write it in a different way. Let me write it. Let us say, let me say valid papers is equal to I plus 1. Now if valid papers is greater than or equal to h, we'll just return. That's it. I think we are good to go. If not, we'll just return 0 there itself, right? uh yeah, here we are. This is our algorithm, and I think we can move forward. Yes, first we'll just change it to nums, and int n is equal to nums dot size. We'll just sort the elements, these nums, in descending order. So sort nums dot begin nums dot end greater int, right? Now for int h is equal to nums of 0, h is greater than or equal to 0, h minus minus. Now for int I is equal to n minus 1, I is greater than or equal to 0, I minus minus. Then if nums of I is greater than or equal to h, and int valid papers is equal to I plus 1, yeah, and if these valid papers are greater than or equal to h, we'll just return h, right? Here we'll break, and will return 0. That's it. So we're gonna submit this, and I think we are good to go. We will meet tomorrow again and tomorrow is Monday. Yeah. So everyone, thanks for attending this live session. We just solved just one problem. You know, yeah, that's great actually. And everyone who have attended this live session, thank you very much. So I think you might have some doubts. So you can just ask me here. Yeah. So, hello, just got uh, 1 second. Here we are. Hi, can you explain lead code number 6 longest server? Sure, brother. Oh god, sorry. I just opened again. Number 6 longest server. Right. No, it's not. It's not longest server actually. It's just a zigzag conversion. Uh, Let me search for it. Longest subarray. It doesn't have problem like that. Have another things. Micro trace one. Hi brother. But the problem number 6 which you are asking is a zigzag conversion. We don't have exactly. Can you just number 3? Okay, longest substring without repeating characters. That's great. Yeah. I think we have this discussed earlier if I'm not wrong. But by the way, we can just discuss it again. And yeah, here we are. Gonna string s, find the length of the longest substring without duplicate characters. 1 second. 1 second. Just give me some time and I'll just explain it clearly for you. You know, when you see this problem, you just don't panic. Just read the problem first. First, we have A, B, C. A, B, C, B, B. You know, the answer is A, B, C, however, without repeating characters. How do you get it, right? But they didn't ask for the substring, they just asked for length of the longest substring without duplicates. I'll just say it as duplicates. Let me tell you one thing. We are asked for length or one thing, substring or subarray, right? There is a chance that this question is a sliding window problem. That's just like, pattern recognition. If I just see a substring or subarray problem, I'll just say the first thing, it might be a sliding window problem. That's where I'll go. But if you, excuse me, if you see this problem ABC, ABC, BB, I'll just need the length, the longest substring, right? Now let me tell you, you might go with this thing like, but before that, let's take the concepts. It is 1E5. Now, first thing, I can take all substrings, all substrings, you know, but one thing, when I'm taking this A, you know, the length or the size is 1 and the characters in it is also 1. Now let's go to AB. AB. Here it is A. The size is 2 and the characters also 2. Now I'll just take ABC. The size is 3 and the characters in it are also 3. Now I'll go to ABCA. ABCA. Now if you see the character, wait a second, yeah. The size is 4 and the characters are just 3. That means there is one character which is repeating, right? The unique characters which I'm saying is just 3 and the size is 4. Now if you just do this again and again, then the brute force approach will be taking you big of n square time complexity, and the space complexity will be big of 1. However, but this big of n square will not work for 1e5, and I think you are eagerly waiting for an approach where you can go it with optimized approach ABC ABC BB ABC ABC BB. And let me tell you how I go with the approach which I have been talking about is sliding window. Just take this, right? I'm just taking this. Now the size is 1 and the characters in it are also 1, so this is valid. So the answer, I think, will be 1y. You might ask me why. Why I'm saying that 1 will be the answer instead of 0. Why? Because the string, okay, oh god, we can also have the string length as 0. If you see, that's why constants are really important, right? So here it is 0. I can get an empty string. Now you see here the characters in it are 1 and the size is also 1. I'm just taking this substring, so it is valid, so I'm just incrementing. And now I have AB. Now the size is 2. The characters in it are also 2. I'll just increment as it is valid. Right now it is size is 3 and the characters in it are also 3. Yeah. I'm just updating the answer, which is the maximum. Now I'll go further. That's where comes the actual problem, where the whole ABCA is the substring which I'm looking for, and the size is 4 and the characters in it are 3. But let me tell you one thing. This isn't valid. Why? Because the size is not equal to the characters in it. So what do you do at this point? Now you know what I think is, you might say that bro, I have took this A, so let me just be here. But one second. What if in future you are not going further, you are just stopping your iteration here, but what in further you might have A B C D, a string like this, substring like this. So what I will be doing, or anyone, the standard algorithm of sliding window will do is, what we did till here, we just expanded the sliding window to right. Now it is not valid, it is no more valid. Now what I'll do, shrink until the sliding window is valid from left. Let me tell you, how I'll do that. Which question? 1 second, Tarun. You got me at the here. The third problem in LeetCode. So BCA, you can get it. So I'm just shrinking the window. If you see, my window was like this, then it was like this, then it was like this, then it was like 1 second, then it was like this. If you see, now when I'm shrinking, I'm just shrinking from the left. I just had A here, A, B, C, A, B, C, A, B, C, A, and I have B, C, A. I just shrinked it. Micro trace. I need to get confirmation from you that you got to know or understood this till here, the explanation, right? And if you got stuck anywhere, please let me know. We just expanded till now, expanded the sliding window to the right. Now we are shrinking until the sliding window is valid from left. Now I just shrinked it. Now, yeah, I think you got it. Yeah. Now the window is BCA. Now the size is 3 and the characters is 3. So, right. Now the answer. Do you think the answer needs to be updated? No. Do you think micro trace, right? I think you don't have to. Yes, I understood till there. Yeah, that's great. That's great. Now, the problem most of the people get as a beginner is the first problem is getting the idea or the approach. Now, I think this is clear for you, micro trace. If this is clear, then we can write what are the data structures used and how to implement our idea in code. How to implement our idea to code. Just putting our idea into this data structures and algorithms. If you are ready, we can go. And the idea is just like a hypothetical window, you know, expanding, expanding until it is valid. And if it is, how can I get approach here? 1 second. There is something sliding window. Yeah, Mukesh, I think you are new to our channel by seeing question. Yeah, that's great. That's many beginners, even me, I used to have this problem. How do I get the approach right for this, easy to medium problems? Let me tell you, there are some tricks, I have to say this. Minimized maximum. Did you ever look like this? Minimized maximum or maximized? I guess you're just beginning. Yeah, I have approach. I just got this approach, Tarun. Right? I just explained about the approach, and we gonna go with the pseudocode, how we can implement it. Right? I'm just explaining maximized minimum. Right? There will be tons of question like this. Maximum minimum of this, of that, blah blah blah. Right? Scanning window with hashmap I j at 0 index expand up to frequency of element became 2 and count j minus 1 for length. That's absolutely perfect, Mukesh. Thank you for attending the live session. Yeah, Tarun, you got it. You nailed it, brother. Yeah, this type of questions we can just simply say it as binary search or binary search. It's like binary search on answers. If you have solved cocoa eating bananas. 1 second. Micro trace how sliding window applying explain at each step, please. Sure. ABC, ABC, BB. Right, here we are. ABC, ABC, BB. Let me tell you, imagine I have a sliding window, then I'll say this is my L, this is my R, inclusive, right? So let me say this is my L and this is also my R. Why? Because I just have the sliding window with just one as the length. You see here L and R. You see the size is, how do I get the size? You might have this problem. The size I can get by R minus L plus 1. Let us think, right? R minus L plus 1, 0 minus 0 plus 1 is 1. Yeah, the size is 1. Now, the unique characters in it are 1. 1 second. Can I know that? Do you know how we get the unique characters in our sliding window, or you want me to explain? No problem if you don't know, I'll just explain it just quickly, right? Just let me know. Do you know, right? I just have 2 pointers here, R and L. I am asking you a question. that do you know uh, how we can get the unique characters from it? Hash set, that's perfect, right? So if you know that, then it will be easier. Now the answer is 1. Now what we'll do, we'll just increment or just expand our window, right? Now see here the size. The size has now changed to 2. Now the characters are also 2. Now the size, if the size is equal to the characters, then I'll update the answer. Previously the answer was 1, now answer is 2. So I'll just update it, right? Now, even here, even at this step, the sliding window is still valid. So I'll just increment the R. However, I'll just keep the L here, right? So here R. Now, the size is 3. The characters are 3. If you see, A, B, C are the characters and the size is just 3. Now, the answer will be updated. Why? Because it is valid. Now, as usual, I'll just expand our window. Why? Because I'm thinking like I might get a greater sliding window, right? A bigger sliding window, which that might be valid. But if you see, the size is 4, the characters are 3. Let me just remove all this. The size is not equal to the characters. The size is 4 and the characters are 3. That means there is a mismatch. You know, there is a duplicate character. Now, at this point, until until the sliding window becomes valid, what you have to do, you have to shrink the window. That's it. And you'll just decrement the hash set. You already knew it, I think so, right? So what I'm doing, I'm just incrementing the L. Now look here, the size is 3 and the characters here are also 3. Now the answer, you don't have to update, right? Now it is valid. So when it is valid, I'll just increment. But when it got stuck with invalid sliding window substring, then we'll just shrink the window, right? Now the R is here. Now if you see, the size again has become 4 and the characters are 3. So I'll just shrink the window. CAB I have CAB, right? Now you see, and the size is 3 and the characters are 3. Now the answer, I think no need to update it. Now I'll just increment my R to here. Now again, you see this? Again I got CABC, right? Again it is invalid. I'll just change it to here, right? Now I'll have till here, right? So it was just changed to 4, here 3. Then I'll just increment it. Are you getting my point, Tarun? Oh, sorry, Tarun, sorry, micro trace, right? CABC, I'm just incrementing or just shrinking the window and I got ABC, right? So here I would get it like 3 and then 3. I think no need to update the answer, right? Till from this step the answer was 3, right? Now what I'll do, here was my R and I'll just increment my R to here. Now I have a B again, you know you know let me remove all this stuff. The size here is 4 and the characters are still 3. Now what I'll do, I'll just shrink the window. Now the size is 3 and the characters are just 2. So I'll just shrink it again. Now the size is 2 and the characters 2. But it is valid, but we don't update our answer. Why? Because answer is already maximum, right? So when I'm updating this answer, I'll just write it like this. So answer is equal to maximum of answer, comma, the size which I have. The size is, however, r minus l plus 1, right? Now I'll just increment the r and the size is 3 and the characters are still 2. There is inequality, so I'll just increment or shrink the L. Then the size is 2 but the characters are 1. Then L will be updated. Then the size is 1. The characters are also 1. Now maximum of 3 comma 1 is just 3. So the answer will remain 3. I think you got it. If you are stuck anyway, and let me also give you standard sliding window template. I'm just saying it as, if I have to build something like ChatGPT, or Codex code, or something like whatever Grok, something like that, I have to give a template code. Then I will use this standard. You can use it anywhere. Standard sliding window template. Let me tell you, we will have this for r is equal to 0, r is less than n, r plus plus. We will have frequency of array of r plus plus, while is invalid. Then here what we are doing, I'll just say that frequency of array of L minus minus, and if frequency of array of L is equal to 0, frequency dot arrays array of L, right? Now L will be incremented. While it is invalid, I'm just doing that, right? Now the answer will be updated. Answer will be max of answer, comma, r minus L plus 1. That's it. That's it. You know, um, okay. What we are doing here is expanding the window, right? Now, if it is invalid window, um, here we are doing one thing, shrinking the window. I think I need to get to know micro trace. Did you got it? If you have anything like you missed somewhere, or you just need to got you need another explanation with an example, please let me know. Shrinking the window until it becomes valid. One thing is, you see here answer, we're updating it only after we are making sure it is valid. So I think that's great to be noted. We are updating updating our answer only after making sure the window is valid. The window is valid. I hope you're clear, Mr. Trace, right? Micro Trace. I hope that's clear. One second. We are still at 1121 subscribers. I think we just have to be more. Yeah. Now I want, uh, I just wrote this for array. I think you can convert this into string and let me know how many problems, instead of I can ask this, like how many problems have you solved it which are in the same like this, the same pattern, right? Okay. So yes, here we are just solving problems. And how many have you attended today's contest? How many? I think I can start a poll. Okay, you just solved one. It's okay, brother. Gave today's. How many attended today's weekly contest? 3 by 4. That's great, Tarun. I think your I think your rating will be updated. Will be spiking, I think. And let me know. Let me start another poll. Let your viewers weigh in. Do you do you want me to explain today's weekly contest problems? Okay, okay. I to be dropping. I was somewhere at the 1850s, but now I would be at the 1830. Yeah, it's okay. I think most of this might be. most of the people had solved it like that, if I'm not wrong. And I think we just have to get more subscribers. Um, and we are just running out of time every day. You see, where is it? Yeah, here we are. Second, yes, Taran. We will go, but let me tell you, uh, sure, we'll go. I'm just having every tab at one place, in every all those tabs in one place. I'm just removing this micro trace. Is that okay? Micro trace, I'm just removing it. I want you to code for this. I didn't attend this today's weekly contest because okay, okay. Maximize the minimum waiting time at synchronized traffic lights. You are given an integer period and integer lights with lights of I is the duration in seconds of the green phase of the ith traffic light. At time 0, every traffic light starts as the beginning of its green phase. The cycles are synchronized. Every traffic light starts a new scale at the same time. Every cycle lasts exactly period seconds. Therefore, the red phase of the ith traffic light lasts for 1 second. You are also given it arrival time, where arrival time is the arrival time in seconds of the jth car. Okay. For car assigned to the ith traffic light, let R is equal time. If R is recent lights of I, its waiting time is 0. Otherwise, its waiting time is period minus R. It's hell very much description. Okay. So I think we are just given with light and period. So what we have to do, well, cycles are synchronized every traffic light. Okay, I'm getting like uh, I know it's binary search on answers. I'm thinking which variables have to be changed. Let us go. Let us go. One second. Imagine, just imagine. There is a car. Sorry, I have some urgent work to today. Catch you tomorrow. Sure, Tarun. We're gonna solve the second problem. However, okay. Now imagine there is a car that arrives at time t. Just like that. I'm just taking an example. There is a car which arrives at time t. Now r, which they set, arrival time of j mod period. Right. So here at our case, I said it which is arriving at time t. So r is equal to t mod period. Now for a for something like this traffic light, we have these durations, multiple cars arrival time. Now if this r is less than lights of I, then the light is green, so the waiting time is 0. Now otherwise the light is red, then the waiting time is period minus r. So the larger L can never make the waiting time worse, right? I think you got it. Now we only need the traffic light having the maximum green duration, right? So the max light should be max of all those lights, right? Then for every arrival we need, let me write it. So first thing will be which contest is this? We go 515. Weekly contest 515, question number 2. So that means for every arrival I need the R as arrival time of I mod period, right? Period. Now if this uh, R is less than the max light, then wait time will be 0, else wait time will be period minus R. So the answer is the maximum of these minimums, right? Max of minimum possible waiting times. So let me tell you, I think we would get it, right? Let me write a simple thing like max light. Max light will be the max element from the lights. Now the answer I am taking is 0 first of all. Now the t will go, I'm just iterating the arrival time. I'll just take r as t mod period. Now if this r is greater than or is equal to max light, then answer is equal to max of answer comma period minus r, right? Now we'll just return the answer at the end. I think that's it. This max of all is enough, right? So let me tell you, yeah, 50% have attended the live session. Sorry, the weekly contest. Now, okay. Let me write it down. I'm just using I'll just use long for somewhere here. Int max light is equal to max element in lights dot begin comma lights dot end. Now int answer is equal to 0. Right, for long t in arrival time, I'll just take long r is equal to t mod period, which is just given for us. Now if r is greater than or is equal to max light, then answer is equal to max of answer comma int of period as r. That's it. Right, we'll just return our answer if I'm not wrong. Right, so yeah, here we are. 1122. That's great. I think we need to get to 1234 subscribers. 1234 subscribers. Right. So here we are. I think if you got any doubt, please let me know.